I am unable to access the content of the specific online forum thread. Therefore, I will discuss recreational vehicle or RV electrical systems in a general context, covering common problems, safety considerations, and basic troubleshooting techniques. RV electrical systems are typically composed of two distinct voltage levels. Firstly, 120 volts alternating current, or AC, which is the standard voltage found in most homes, and secondly, 12 volts direct current, or DC, which is commonly used for powering lights, pumps, and other low voltage appliances. The 120 volts AC system is usually powered by an external shore power connection at a campground or through an onboard generator. When connected to shore power, the RV electrical panel distributes electricity to various outlets and appliances. The electrical panel contains circuit breakers that protect the system from overloads and short circuits. It is crucial to ensure that the shore power connection is properly grounded to prevent electrical shock hazards. The 12 volts DC system is powered by one or more batteries that are typically charged by the RV alternator while the engine is running, or by a converter when connected to shore power. The converter takes 120 volts AC power and converts it to 12 volts DC to charge the batteries and power 12 volts appliances. Fuses are used in the 12 volts DC system to protect individual circuits from overloads. Understanding the RV wiring diagram is essential for troubleshooting electrical problems. The wiring diagram shows the layout of all the electrical circuits, including the location of circuit breakers, fuses, switches, and appliances. Before working on any electrical system, it is crucial to disconnect the RV from shore power and turn off the generator to prevent electrical shock. Always use a multimeter to verify that the power is off before touching any wires or components. Common electrical problems in RV include firstly, blown fuses or tripped circuit breakers, secondly, faulty wiring, thirdly, corroded connections, fourthly, and dead batteries. Blown fuses or tripped circuit breakers are often caused by overloads or short circuits. If a fuse blows or a circuit breaker trips, it is important to identify and correct the underlying problem before replacing the fuse or resetting the breaker. Faulty wiring can be caused by damaged insulation, loose connections, or improper wiring techniques. Corroded connections can occur due to moisture and exposure to the elements. Clean corroded connections with a wire brush and apply a dielectric grease to prevent future corrosion. Dead batteries can be caused by excessive use, lack of charging, or age. Regular maintenance of the RV electrical system is essential for ensuring its safe and reliable operation. This includes inspecting wiring for damage, cleaning connections, and testing batteries. When making electrical repairs or modifications to the RV, it is important to follow all applicable electrical codes and safety standards. If you are not comfortable working on electrical systems, it is best to consult a qualified electrician. Here are some specific areas to consider for RV electrical systems. Firstly, battery maintenance. RV batteries are typically lead-acid batteries, either flooded or sealed. Flooded batteries require regular checking and refilling of the electrolyte level with distilled water. Sealed batteries are maintenance-free but have a shorter lifespan. Batteries should be charged regularly to prevent sulfation, which can reduce their capacity and lifespan. Battery chargers should be matched to the battery type to prevent overcharging or undercharging. Secondly, generator maintenance. RV generators provide 120 volts AC power when shore power is not available. Generators require regular maintenance, including oil changes, spark plug replacement, and air filter cleaning. The generator should be exercised regularly, even when not in use, to prevent fuel system problems. Thirdly, shore power connections. RV typically use a 30 amps or 50 amps shore power connection. It is important to use the correct adapter when connecting to a different amperage service. Extension cords should be heavy duty and rated for outdoor use. The shore power connection should be inspected regularly for damage or corrosion. Fourthly, electrical panel maintenance. The electrical panel should be inspected regularly for loose connections, corroded terminals, and damaged circuit breakers. Circuit breakers should be tested periodically to ensure that they are functioning properly. The electrical panel should be kept clean and dry to prevent corrosion. Fifthly, wiring. RV wiring is typically stranded copper wire. The wire gauge should be appropriate for the amperage of the circuit. Wiring should be protected from physical damage and exposure to the elements. Wiring connections should be secure and properly insulated. Sixthly, lighting. RV typically use a combination of 120 volts AC and 12 volts DC lighting. 12 volts DC lighting is more energy efficient and can be powered by the batteries when shore power is not available. Light bulbs should be replaced with energy efficient LED bulbs to reduce power consumption. Seventhly, appliances. RV may include a variety of appliances such as refrigerators, air conditioners, microwaves, and water heaters. These appliances can consume a significant amount of power, so it is important to manage power consumption carefully. Appliances should be inspected regularly for damage or malfunction. Eighthly, grounding. Proper grounding is essential for preventing electrical shock hazards. The RV electrical system should be grounded to the chassis and to the shore power connection. Grounding connections should be inspected regularly for corrosion or damage. Ninthly, surge protection. A surge protector can protect the RV electrical system from voltage spikes caused by lightning or power surges. Surge protectors should be installed at the shore power connection. Tenthly, safety precautions. Always disconnect the RV from shore power and turn off the generator before working on the electrical system. Use a multimeter to verify that the power is off before touching any wires or components. Wear rubber gloves and safety glasses when working on electrical systems. Never work on electrical systems in wet or damp conditions. If you are not comfortable working on electrical systems, consult a qualified electrician. Understanding basic electrical principles is helpful for troubleshooting RV electrical problems. Firstly, voltage is the electrical potential difference between 2 points. It is measured in volts. Secondly, amperage is the rate of flow of electrical current. It is measured in amps. Thirdly, resistance is the opposition to the flow of electrical current. It is measured in ohms. Ohm's law states that voltage equals current times resistance, or volts equals amps times ohms. This law can be used to calculate the voltage, current, or resistance in a circuit if the other two values are known. Power is the rate at which electrical energy is consumed. It is measured in watts. Power equals voltage times current, or watts equals volts times amps. This equation can be used to calculate the power consumption of an appliance if the voltage and current are known. When troubleshooting electrical problems, it is helpful to use a multimeter to measure voltage, current, and resistance. A multimeter can also be used to test for continuity, which is a measure of whether a circuit is complete. The multimeter should be set to the appropriate range for the measurement being taken. Follow the manufacturer's instructions for using the multimeter. Here are some additional tips for troubleshooting RV electrical problems. Firstly, start with the basics. Check the fuses and circuit breakers to make sure they are not blown or tripped. Check the battery voltage to make sure the batteries are fully charged. Check the shore power connection to make sure it is properly connected and grounded. Secondly, use a systematic approach. Start by isolating the problem to a specific circuit or component. Use a wiring diagram to trace the circuit. Test the voltage, current, and resistance at various points in the circuit. Thirdly, look for common problems. Check for loose connections, corroded terminals, and damaged wiring. Check for signs of overheating or burning. Check for water damage or corrosion. Fourthly, consult the owner's manual. The owner's manual may contain troubleshooting tips and diagrams. The owner's manual may also contain information about the RV electrical system. Fifthly, seek professional help. If you are not comfortable working on electrical systems, consult a qualified electrician. An electrician can diagnose and repair electrical problems safely and effectively. Remember that electrical systems can be dangerous, so it is important to take precautions to prevent electrical shock. Always disconnect the power before working on electrical systems. Use insulated tools and wear rubber gloves. Never work on electrical systems in wet or damp conditions. RV electrical systems are essential for providing power for lighting, appliances, and other equipment. Understanding how these systems work and how to troubleshoot common problems can help ensure a safe and enjoyable RV experience. I hope this overview of recreational vehicle electrical systems is helpful. Without access to the specific forum thread, I have provided general information on RV electrical systems covering common problems, safety considerations, and basic troubleshooting techniques. This should offer a foundation for understanding and maintaining your RV electrical system.